is based around Sybase IQ, and Courtney Claussen, Director of Product Management for SAP Sybase IQ, is going to be our main presenter today. And we'll get to Courtney in just a few moments. Just to give you guys a heads up, the next TechCast in this series will be on a replication server. We'll be talking about futures and a roadmap presentation, and Chris Brown, who many of you know, will be our presenter for that session. And that will be December 11th, same time. And registration for that will be open tomorrow. And you will be able to log on to the ISOC site and get that registration information. You can always go to our website and click on the events and look at the upcoming events, and you can land to the registration page from there. Speaking of future events, we're pleased to announce that ISOC Tech, in conjunction with our partners and SAP, will be holding its annual conference in Atlanta, Georgia next year. It'll be from April 14th through the 17th, and it will be held at the Hilton Hotel downtown Atlanta. It's a wonderful location. And currently, the call for papers is open. It says the early bird registration is open on the slide. The early bird registration will be open in about an hour at the end of this TechCast. So you'll be one of the first people to get an opportunity to register. Plenty of information online about the conference. If you are interested in submitting a paper or a session for the conference, whether it be a lecture, a workshop, birds of a feather session, roundtable discussion, whatever you think will be of interest to attendees, you can do so during our call for papers, which is open now. The link is on the screen. We do encourage you to share your experiences with your fellow conference goers if you want to attend. Registration for the conference will be no more than $1,200. We are offering a discounted rate to our ISOC Tech Gold members, who will receive a lesser rate than that. And currently, our special early bird registration special, which is really cool, is that we will be including the 3 nights of hotel for the conference, Monday, Tuesday, Wednesday nights, in your registration fee for the first 250 people to register. So if this is an event you want to attend, this is a great opportunity to attend the conference at the best possible rate and get your hotel accommodations included as well. So please do check out our website and look out more information about that. And we'd love to hear your feedback on that too. So please do feel free to contact us. And our contact email, which is not on the screen, I apologize, is conference@isug.com, and we'd love to hear from you. So on to today's session. And our featured presenter, Courtney Claussen, known Courtney a very long time, wonderful speaker, great information. We're so pleased you guys joined us today for this. And Courtney is going to tell us all about the cool things in Sybase IQ, or I should say SAP Sybase IQ, version 16, which is currently out. And Courtney, if you're ready, I'll pass it over to you.
Okay, thanks very much, Mike. Let me just show my screen here. Whoops, hold on. I'm afraid you might be seeing my screen and a control panel here.
You're fine. Go ahead.
Does it look all right? Okay, great. Well, thanks everyone for joining today's webinar. It's always a treat to speak to our customers and users of IQ. Today we're focusing on the features of SAP Sybase IQ 16, a platform for big data analytics. We have a wealth of new features in the product around big data analytics that I'll be sharing with you today. And it's important not only to have a platform that can handle all the aspects of big data, the volume, the variety, the velocity of big data, but you also need capable and sophisticated tools to manage and monitor that kind of an environment. And we have Bradmark on the call today to talk about what they have to offer in this area. So let's just dig in. As I said, the IQ 16 release was designed for big data analytics. And why is this important? Well, it's a new world. Businesses today need to apply analysis to new areas. They must provide decision makers with actionable results in seconds. Companies must analyze massive amounts of data with real-time data analysis to ensure that results are not out of date before they're even used. Plus, they require access to less critical data to perform historical or trend analysis. Big data is changing the traditional data management platforms by driving analysis to take place closer to the data source and driving the need for analytic calculations to happen at greater speeds so as not to delay critical functions. So IQ16 brought in a whole slew of features around this to deal with better and faster data ingest, to scale the column store, to have even more higher performing queries. Also some additional features around data protection and resiliency of our multiplex cluster. I don't know how many of you are familiar with the Guinness World Record that we achieved this past year. It was a world record around the fastest data loader. And with a simplex IQ server on commodity hardware, we achieved a really spectacular rate of over 34 terabytes per hour of data ingest. This was a mixture of structured and unstructured data, multiple ingest streams going on concurrently. One of the other exciting things about that record is not only did we achieve this peak rate of over 34 terabytes per hour, we had a sustained rate of at least 30 terabytes an hour through the whole test, even as the tables and indexes grew and as storage began to reach closer to capacity. So we were very excited about this world record. Currently, we're engaged in another large benchmark. We're hoping to achieve yet a new world record around the world's largest data warehouse. So stay tuned for that. We'll be obviously having lots of press around that. So let's move on. Big data analytics is becoming a very powerful business tool. It's not just a buzzword. There are true return on investment that's quantitative by applying big data analytics. You can see a whole lot of different use cases and verticals here across healthcare and supply chain management, customer sentiment analysis, financial analytics. But a few things you see in common among all of these is that they all are based on having access to the latest data to be able to perform very complex queries around predictive analysis, to also be able to analyze large volumes of data from many data sources, and also to be able to handle both structured and unstructured data. These are the various characteristics of big data that any big data platform has got to be able to handle. The data management and analytics platforms we've relied on for decades have been relational databases, but big data has stretched their capacity to a breaking point, and new technologies are now required to handle the volume and variety and velocity of big data. We now need software that can stream and capture machine-generated data. We need new algorithms that can detect patterns in data, understand the grammar and context of human language, that can correlate spatial data with digital events. And at the hardware level, a scalable yet economical storage layer is absolutely critical to handle the extreme volume of big data. Sybase IQ 16 was the biggest release in IQ history. We went back to the foundation of the IQ store because we were moving from VLDB to XLDB. VLDB was terabyte, hundreds of terabytes scale of data sets. XLDB, we're now moving up to the petabytes of data, which is becoming more common all the time. And this required going back to the foundation layer of IQ. We re-architected the column store. You'll see some details on that coming up. We also did massive improvements to the loading engine. We continued improvements to the query processing engine, which matures and gets better all the time anyway, but we did some really innovative work in the query engine as well, which you'll see. And then system reliability. It's really important with big data as larger volumes of data, more complex queries, jobs that perhaps run longer because of the massive amounts of data they're dealing with. It's critical that your system be resilient, that if there's any kind of interrupt in system service in the network or a machine that might go down, that the cluster can stay resilient and continue to do the processing that you were doing. So we made some improvements to the multiplex to increase its resiliency and robustness. IQ has always had superior compression characteristics. We have lots of real-world examples from our customer base where we have significant data compression on all different kinds of variety of data. And IQ and all column stores in general do very, very well in this area compared to traditional row-based stores. And we've made even further improvements in our column store to achieve greater levels of compression. So here are the details on that. On the left bottom side of this slide, you will see a picture of a logical page of fixed size cells. This was the page structure of the IQ database. And each one of those cells held a particular column value in a particular row of a table. This was set up as a fixed sized cell grid. And the reason for that was that it allowed for very quick access to particular data with an offset calculation. This particular architecture was a good foundation for IQ for a long time through VLDB, through terabyte size databases. But what's happened now is that as we get even larger and we have more unstructured and variable size data, that a fixed size cell architecture is going to be wasteful if you have variable size data. Because, for example, if you have each one of those cells is holding a 256 character varchar, and many of those cells only have a smaller amount of data than 256 characters, there's some amount of waste for each one of those cells. So we went ahead and re-architected the column store to allow there to be a variable page format with variable length pieces of data that are compressed very closely together. Now, what we can't do anymore is that quick offset calculation to find a particular column value. So we needed to add some metadata to each page, which was done in such a way as to be relatively sparse, so we're not eating up the entire page with indexing to find cell values. But this allowed us to achieve much, much better compression with variable size data. So as you can see, we went right back to the foundation of IQ and did some significant work to support petabyte scale data. Another thing we did in this area, for those who are IQ users, you know that when data is loaded into IQ, it is immediately indexed. The data is immediately stored as an index, and it is stored with dictionary encoding. Basically, we have a table with all the unique values for a column, and what's actually stored in the data pages are integer lookups into that dictionary. So we had the SP1, 2, and 3. These were 1, 2, and 3 byte fast projection indexes, meaning that if you had a cardinality of data that could be represented by a single byte, it would be an FP1. Once the cardinality got big enough to require 2 bytes, you go to FP2 and then up to FP3. But once again, we wanted to get maximum efficiency out of the column store. So if you have 2 unique values, for example, a whole byte to represent those different values is wasteful right there, because you only need a couple of bits to represent that. So we've gone to n-bit encoding for our dictionary compression. So it will only use the required number of bits to represent the cardinality of data. So we achieved better compression from that standpoint as well. So that's at the column store foundation of IQ. We improved the page format, we improved the compression with n-bit dictionaries. So we're getting every bit of efficiency out of our underlying store to be able to compress and cram as much data as possible into the underlying store. This slide is starting to move into the data loading improvements that happened with IQ. We added some loading improvements around our fully parallel bulk loader. We have incremental bulk loading improvements and a new real-time write-optimized delta store. These are the improvements that came around fully parallel bulk load. This is the familiar load table command or insert location. And the way the algorithms used to work before IQ16 is that it was partly parallel processing and partly sequential processing. And there were various bottlenecks and expensive synchronization points. So what happened was we took all those loading algorithms and pulled them apart, reshuffled the pieces, and allocated them to threads in a more efficient manner. So all threads are doing productive work all the time. All phases of loading are now completely parallel. We also changed our HG, or high group index. This index has a very rich metadata for the query engine so that it can quickly access data during queries. But the HG index is a B-tree structure, and it can get very bushy as the table size grows. This is critical in these petabyte scale deployments. So what would happen is even loading the same amount of small data over time gets slower and slower and slower because that index gets bushier and larger and hits more pages in the database. So we changed the structure to a tiered structure, and the smallest tier is utilized to do the incremental load. As soon as that load commits, the load is finished and the IQ engine can go off and do other things. And in the background, these small tiers of HG indexes merge into the main HG index structure. So finally, everything becomes consistent. And then the third area of loading is our write-optimized delta store. So this is a new piece of technology in IQ that is not table-level locking like you're used to, but has row-level locking properties so that you can have multiple writers to the same table at the same time. And what happens is that behind the scenes, as you're loading data, it will migrate down into the main store. This in-memory delta store has some different properties. It's minimally indexed, minimally compressed. It has its own write-ahead transaction log designed for really, really low latency writes. This has been really exciting technology. It lets IQ get beyond its bulk loading, batch loading characteristics and become a true multi-writer data ingest engine. Now we're going to move to the query improvements that were made. These are around something called data affinity and then improved parallelism and distribution of queries. So we've added some hash partition tables that lets at load time for the data to be partitioned into these buckets. And this allows the query engine to already have pre-partitioned data that it can pass to different nodes or different threads for parallel processing. And because it's already pre-partitioned, it's that work doesn't have to be done at query time. And this next slide shows this capability of data affinity. So we've got these hash partition tables. Distributed query processing in the past would able to break a query into fragments, pass those fragments out to different machines in a multiplex, and then all the work was done in parallel, and the results aggregated back together. But what would happen is these work assignments were done fairly randomly, and the query optimizer didn't track which machine already had which data set in cache. So caches would have to be flushed, data read back in from the shared store. So the query optimizer now makes use of something called data affinity. It tracks cache contents across the multiplex, and it assigns distributed query work intelligently. It passes the work assignment to a machine that already has the data in cache. So the caches stay warm, much less I/O to the shared store, and query performance is much, much better. We also have done increased improvements to the different query operators and made them more parallel, more distributed. There's always improvements being done in the query engine in this area. So we've covered the foundational column store improvements, the loading improvements, the query improvements. We also made some improvements around security and resiliency. So first, we've added LDAP authentication to complement our Kerberos authentication mechanism, and we also have, of course, our IQ native logins that you can make use of. LDAP is a very popular authentication mechanism, and we now have added that into IQ. We've also added something called row-based access control. This is very granular authorization based on a standard. Lets you have very, very tight control over who has access to what data and what they can do with that data. We did a really complete implementation of this standard, and I think you'll be very happy with the capabilities and control that you have over data security with this new feature. Quickly moving on, multiplex enhancements. We have improved the transaction resiliency, so if a node goes down, queries continue to run, they don't roll back and have to be resumed. We have some login redirection capabilities. If a server is down in a logical server, your connection will be redirected to another physical server. And there have been some additional improvements in this area. Here's a picture of the transaction resiliency. There's a heartbeat mechanism that happens all the time between the coordinator and the other nodes in the multiplex. And the various nodes know when someone is up or down. And now that beyond that, if there is an interrupt in network connection, or if a server happens to go down, what used to happen is the query would have to roll back and be restarted. No longer. That query can suspend and resume when service is restored. So I want to kind of move through because we have a very important part of this presentation coming now with Bradmark. Just a quick recap here that that with big data analytics, it's important to achieve better query times, better data ingest rates, and to achieve the promise of big data analytics that our customers are beginning to be able to make use of. Here's some of our IQ resources, and obviously some of our bragging rights that IQ has held for a long time, patents and leadership recognition, Guinness World Record holder. Very exciting product with lots of innovations happening in the past and continuing to happen in the future. So thanks very much, Mike. I'll let you turn it over to our Bradmark presenters.
Thanks very much, Courtney. Appreciate that. Folks, if you've got any questions about that presentation, please do submit them through the Q&A console, and we'll come back to Courtney at the end of the presentation to answer those questions that you may have. Move on to the second presentation. Bradmark is going to talk about Bradmark surveillance and monitoring of IQ, particularly the multiplex in version 16. So, Bill, it is all yours.
Okay, Mike, thank you very much. Can you see my screen okay?
Yes, we can.
Okay, thank you very much. So, and also thank to all the participants for joining us today. You know, we just heard Courtney talk about how SAP Sybase IQ 16 makes it simpler, more cost-effective to exploit the massive amounts of data that businesses today are really consuming at just record speeds. So what does that mean to us as DBAs who are responsible for monitoring the performance of our IQ databases? I mean, now we're dealing with huge amounts of data being stored in IQ and other databases. We're also dealing with the real-time aspect or the real-time rate of data access that our users require today to perform their analytics. So how do we manage this? How do we monitor that? And that's what I'm going to be talking about today. Is how do we monitor an SAP Sybase IQ multiplex? Monitor it at a rate, keep it performing at a rate that our users require. So as I talk to different DBAs, some of them customers, some of them prospects and things, there's the DBAs that are responsible for the performance and availability of IQ databases. I'm sorry, I seem to have lost my screen for a minute. Are we still there? Can you guys hear me?
Yeah, we can still see, Bill. Go ahead.
Oh, okay. I apologize for that. It looks like we had the internet there. So let me go ahead and put this in slide mode and resume here. Once again, I apologize for that. So when I talk about to the DBAs about the different ways that are monitoring techniques they use for IQ, I generally hear three things. And that's we've got monitoring by examining the Sybase IQ message file, looking at the SQL log file for SQL statements. We've got command line tools, different ways to schedule the execution of stored procedures. For instance, the IQ sysmon that gives us information on buffer cache usage, memory threads, locks, etc. There's other stored procedures available that provide information on query execution, like table index, column usage, things like that. And then on the market, there's some graphical monitoring solutions that use a lot of these same techniques here, looking at the message file, the SQL log, executing storage, stored procedures. But they present this data to us in a graphical way that makes it easier for us as DBAs to digest and make sense of the data that we see. A few examples of those are Sybase Central, Sybase Control Center, and Bradmark Surveillance DB. So for this presentation, I'm going to focus on the graphical monitoring and alerting capabilities of Surveillance DB for IQ. So when we're looking at monitoring IQ, there's some key metrics that we want to focus on. Okay, we want to know what is the status of our multiplex. Are the nodes up or down? How are they performing? What are they doing? We also want to look at the IQ database at a global look. So what is the server health overall of our IQ database? Of course, we want to examine the storage and memory. We want to look at DB space and external space utilization. We're concerned with the transactions, the active transactions running, the connections coming into the database. How are they performing? What resources they're using, things like that. SQL, we need statistics on SQL to determine what that SQL is doing and to be able to diagnose problems that arise from SQL that's not executing as efficiently as it should. And then we need an easy way to look at our system and server settings in the IQ database. So I want to talk just briefly about the Surveillance DB architecture. And the architecture is a client-server architecture. On the right-hand side of the screen, you can see the server components that do get installed on the server where the data server resides. So at the heart of the server components is what we call our Session Agent Manager, or the SAM. And the SAM controls all of the service subagents and the collection subagents that you see here next to the SAM module. Okay. It also controls all the communication back from the server to the client. So clients make so users make a connection through the client to the SAM, and that's how they get the information from the different agents running on the server. Okay. There's three main sub-agents. There's an analyzer, alerter, and a repository. And I'll talk a little bit about what each of these service sub-agents do as we move through the presentation. So we also have the collection sub-agents, and these are the agents that automate the efforts that a lot of us are doing, running the stored procedures manually or through command line or scheduling through cron or however we do that. So the collection sub-agents automate that process for us, and they're responsible for extracting the data that we need, the metrics on performance, space, things like that, from the IQ server database. Okay. The data that we collect is stored locally on the server where the database resides. It's actually stored there for a couple of reasons. One of those is for a feature that we call data flashback, which allows us to go back in time, whether it be hours or days, to look at problems that occurred in the past. We also realize that we need long-term data for trending, capacity analysis, and things like that. So that data is also stored in a repository database that we can access through Surveillance's report viewer or any other ODBC compliant software. Okay, so that's the architecture. We're collecting the data, we're storing that data locally for quick response, and we're also moving it to a historical database repository. So we'll touch on each one of these features as we go through. The first sub-agent, the analyzer, is responsible for checking the collected data values that the collection agents return against rules to determine if events have occurred in our environment. Okay, so on the left-hand side, lower left-hand corner here, you see some of the rules that are available for IQ. Some file size for the catalog, IQ message file size, message errors, oldest transactions, open transactions. So there's a host of rules that are provided with the product that monitor different aspects of your IQ server. So these rules contain parameters or thresholds that the analyzer can use to see if anything unusual is happening in our data server. So for instance, if the base is growing too rapidly, or there's errors in the IQ message file, or if the main storage percentage use is high. So things like that, we can monitor. The analyzer can compare those statistics and issue an event once if that threshold is actually breached. So we have out-of-the-box rules that provide standard parameters for this threshold monitoring. We can also, the users can use the client's console to edit the existing rules or to add new rules that are specific to their environment. So it's very easy to copy rules, change rules, edit rules, create new rules. On the right-hand side, we see some of the definitions of the multiplex status query node down rule, and so it's looking for particular nodes that are not running. So the message is that this particular server name, this particular node is down. So if a node in the multiplex comes down, the alerter will detect that issue event, and then we'll get notified of that problem. So how does that happen? Well, the analyzer forwards the events to the alerter sub-agent process. So the alerter processes the event and uses what we call event handlers that are defined in surveillance, and those event handlers will receive the event and perform one or more actions. Okay, and again, the client console is used to edit the existing event handlers that come with the product or to add new handlers. So the three screens at the bottom on the left, we see a default handler. If I edit that, I can see that I'm looking at all the servers, all the different entities. I'm actually just looking for anything that's happening according to the rules that we saw in the analyzers. If I get an event I'm going to throw a pop-up on the screen, and then I'm going to also email this to a specific email address. Okay, it's very easy to alter these or create these. If I want to add another action to this, I can use the console to do that. Other actions are execute console scripts. I can forward these. You can set up event management and surveillance where you have a central alerting server that handles all the event processing and allows you to look at all the different servers that you're monitoring by logging into one central server. So you can view all the events, all the statistics, everything that's happening across your server farm, all your IQ databases from one central console. We can also integrate with other event management software like Tivoli, OpenView, things like that, or others that use S&M traps. We can also, as an action type, create S&M traps in those two event handlers. So let's take a look at what we can actually see when we're using this surveillance product. So here you can see I'm connected to a SAM called CentOS 64, and I'm monitoring a Sybase IQ multiplex, and here I have my nodes, my different nodes, my coordinator, my reader, and my writer. So what I'm looking at here is a real quick status. Is my multiplex up or down? Okay. So I can see the server names, I can see the roles here, and if I look here, I can see that one of my readers is down. Okay, so the status has changed to down. Here's the host for it that particular node's running on. Here's the port that's used to access that. Okay. Now I can also see that if I look at my interconnect, my multiplex interconnect, I can see that the reader here is not responding. We know that because it's offline, but it's also not responding for 58 seconds. Okay, so here's the last time that we were able to contact it. Here's how long it's going to be before it hits the timeout, and so we can get immediately notified that this is down. So at the bottom we see the events that are issued from the event handler that we looked at on the previous slide. So here it tells us that the reader's down on this particular server. It's unavailable. It's been disconnected. Also had a notification here. IQ's down, entity down, entity disconnect, MPX node down. So these are the actual event IDs in the rules that allow us to detect this and tell us that that's down. So what we have is a high-level thing here that allows us to quickly look at the multiplex and see which nodes are up or down. Allows us to respond very quickly to those. If we're not connected with the console, then we've got the events that are being fired, sending us emails, doing pop-ups in whatever kind of notification we've got defined. Okay, one of the important things is to have an overall view of the entire, the entire IQ data server. So here's a global server health window, and you can see that on the left here we've got different configuration things about it, the versions. We've also got current activity, oldest transactions, how many open transactions, how many threads. On the right-hand side here, we're monitoring our storage. We've got main storage, which is the sum of all the DB spaces. We're also monitoring the temp storage. And as you look at these, as these approaches the threshold, then you'll see these diffs turn different colors. We can also alert off of this as it rises. We can set various parameters for warning all the way up to critical. Okay, so here we have our IQ memory. We've got our main temp heap cache memory looking at. We also have statistics on our buffer utilization. We're looking at this two different ways from main and temp. Cache misses the same way. We're looking at those main and temp. We're also looking at other versions, and we're looking at the size that's accumulating from transactions that are holding different versions of our objects there. So we're tracking that. And any of these key statistics that you see on this global server health window can be set up for the analyzer thresholds and for the alerter to notify us with events if anything occurs. Looking at data space utilization, this is a breakdown from the global health window that we were just looking at. Here we see the IQ system main. That is the total size of all the database spaces that make up the main store. We're also monitoring the temp here. If there were any other DB spaces, we'd be monitoring those too. We get the percent used, the total size, how much is in reserve. By right-clicking on these cylinders, we can also go down and get some more detailed information. Where are the files for this? What objects are contained in there, things like that. So at the bottom, you can see that this is a drill down. I can see my DB space name, what kind of segment is it. Here's the actual path to it. It's online. Here's the percentage, the size, first block, last block, stripe size, okay to drop, information of that. So we can get a high-level view of our DB spaces, and we can also drill down for more detail. We're also concerned about external space usage, and these are IQ files that are actually not in the database but in the operating system. So we're looking at our catalog stores here, so we get what it is, the file size, free space available, and where these are actually located. Okay, so we're checking here, we can see the catalog store, transaction log, message log, server log directory. And again, we can alert on these if any of these are extending past our threshold. Okay. We're also concerned about transactions, so we're tracking all the open transactions that are hitting our IQ database. Here we can see things like the name of the transaction, who the user is. We can also look at the state. These are active, these are committed. We have details on how much main storage it's using, how much temp storage is it using, and when it was created, and the create time and the elapsed time for this particular transaction. I can right-click on any of these transactions and get down to connection detail. And the connection detail is going to give me more detail and execution metrics for the connection that I've selected. So I can see things like cursors, threads, transaction IDs, login time, last request time from this, who is the user. I can see the user ID, client host, and what this is actually executing, and the IP address that this connection is coming from. On the bottom half, I've also got additional information about cursors, locks, and all the SQL that this particular connection has executed. Okay. We're also concerned about things that affect performance, so we're looking at block processes. We give you a way to analyze those. Here you see a high-level view of the blocking process and the waiting processes here. So we get a complete hierarchical tree view here of those. We can click on any of these connections and we can get connection detail, which would be very similar to the connection detail we saw on the previous screen. If we have proper database authority, we can also kill any of these connections, either the blockers or those connections being blocked. So we can resolve the block process problem directly from this screen. So in SQL, at the top here, we're looking at the current executing statements. So here I see the user or application that's issued the SQL, when it started, and I can actually see the SQL that it's executing and the elapsed time that it's running. I have some additional administrative functions here. I can, again, drill down into the connection detail, the connection that's actually running this statement. Or I can kill this connection if I want to, things like that. I'm also looking at recently executed SQL here, and this is SQL that's executed within the last 10 minutes or so. The current executing statement is real-time statistics. That's one thing that I should have mentioned up front, is that we're actually querying the database, and the statistics that we're presenting are real-time statistics. Okay, so there's no lag time here. We see things as they are occurring in the database in real time. But for this window, we're going back to the local data store, and we're going back 10 minutes in time, and we're pulling out recently executed SQL. So right-clicking on any of the SQL, I can see, I can view the SQL text. I can do that in a couple of ways. I can hover over a statement, a window will pop up, show me the SQL, or I can right-click and view the SQL text and save that off if I wanted to talk to the application developers about that. So we have a lot of ways to look at the current and recently executed SQL. Okay. The last thing I want to talk about is the system and server settings. We have a quick way to go in and look at all the settings for the default public user here. So you'll see all the options, what the settings are. We can also see other user options, and we can also see the server options down here in the bottom right-hand side. We're looking at the server options. We can also, from the administrative aspect, we can right-click on this and change the values of these. So if we need to make a change to our parameters, they're at our fingertips. We can quickly get those and we can change them. And of course, you're going to need a DBA login for this, proper authority, and specify the new value, and then those can be changed. So in summary, Bradmark's been a Sybase strategic partner since 2005. In addition to the surveillance line of products for ASC, IQ, Rep Server, and other databases, we're also resellers for the SAP Sybase database itself. So we can help you with that, and we can also help you with the tools to monitor those. We're also SAP's recommended solution for SAP Sybase database monitoring technology. Some of the values of surveillance is that we automate the collection process, so you don't have to keep up with your scripts, you don't have to schedule those, you don't have to run those, you don't have to figure out what the data is really telling you for that. We actually automate the entire collection and data store process. We provide the dashboards that facilitate problem isolation. All the data is presented. There's multiple ways to look at the data through the screen, sync those up to help you isolate and remediate problems. And then surveillance also provides automated event management. So if you're not at your desk in the console connected to surveillance, the automated event management is still occurring in the background. Any thresholds are exceeded, any problems with your IQ database, we're going to automatically alert you on that. So that pretty much concludes my portion of the presentation. I want to thank you again for your time, and at this point I'll turn it back over to Mike.
Thank you so much, Bill. I appreciate the presentation. We're going to move into the Q&A section right now, and so Bill and Courtney will be available to take your questions. Again, as I said at the beginning and during the switchover, if you have a question, please do submit it via the question panel on the GoToMeeting console. We only have a solitary question on the console right now, so if you do have a question, please go ahead and enter that question now so we don't close the broadcast and the TechCast before we have finished answering your questions. The first question is to you, Bill, and it basically asks which database engines the Bradmark surveillance tool will monitor.
Which database engines? Okay, so we were speaking specifically about IQ today, but we also monitor ASE. We also monitor Rep Server and IQ as well. We have products for DB2, DB2 LUW, and we also monitor Oracle and SQL Server, Microsoft SQL Server.
Okay, great. Thank you very much. And a follow-up question to that is, does surveillance do any operating system monitoring?
Absolutely. I didn't show the operating system module, but in the screen, when I was going over the architecture, one of the collection agents is for the operating system, and it collects things like CPU utilization, I/O, disk usage, things like that. When you purchase one of the database monitors, it automatically comes with the operating system module, and there's a accompanying set of analyzer rules and event handlers for that also.
Okay, is that both Unix and Windows platforms?
Yes. We support all the major OS flavors, Unix and Linux.
Okay, great, thank you. All right, do we have any other questions on the console? I don't see any. Yes, one just came in, just in time. So I think this is very specific to within what some monitor is version. So it would cover obviously 15.5 and 15.7 in the ASE world that we know. Replication server 15.7.
Yes.
The latest version IQ 15 and 16, and probably 12.5 and 12.6 as well, right? 12.7.
Yeah, we actually go back to 12.5 is where we start. Of course, there's different things we can do with the different versions. I'm going to have to go through the chat response, Mike, and see what exactly is available on IQ 16.
Okay.
That way.
And as far as the other the DB2 Oracle and SQL Server, I assume all that information is probably on the website as to what versions you support. Is that correct?
That's correct.
Okay. All right. And I think we've got one other question coming in, and the questioner is still typing. There we go. So, Courtney, question for you. In the new FP Enery IQ architecture, does the page work kind of like it did in ASE with variable length rows and a row offset table at the bottom of the page? Pretty technical question.
I don't know if it's set up exactly like ASE, but basically the data is written from the top of the page down. The metadata for finding particular column values grows from the bottom of the page up. It's done in a fairly sparse way, so only particular pointers to some of the cells are stored in that metadata, and then there's a scan forward from the address that it specifically has to a column value to scan to the particular one you're looking for. So it was a balance between fast metadata, enrich metadata, and not using up too much space in the page.
Okay, very cool. Thank you. So there's some similarities, obviously, even if they don't work exactly the same way. Okay, great.
So,
all right, I'm not seeing any other questions on the console, and I'm not seeing any indications of anybody who is entering a question. So with that said, I think we will call it a day today. Thank you, everybody, for attending, and thank you to Courtney and Bill for presenting today. And we will have the recording and also the slides online, usually within a couple of days, if not sooner, on the ISAC Tech website. And all attendees will be able to access the recording and the slides from the website. And
hey, Mike, this is Bill. Excuse me for breaking in. I just got an email back from support. We do support IQ 16.
Okay, there we go. So somebody from the Bradmark support is listening in. Thank you very much. So we're able to wrap that question up. So everybody have a great day. Thanks for joining us. And remember, December 11th, we will be looking at Replication Server and looking at some futures in Rep Server, and also the roadmap for 2014 and belong. And don't forget to check out the ISAC Tech website for information about our conference in April, and hopefully we'll see lots of you guys there. Thank you very much, and have a great day, everybody.